In modern software development, the CI/CD pipeline acts as an automated assembly line. It continuously builds and deploys code, passing every update through strict security checkpoints to ensure it is safe for production. For over 10,000 enterprise environments, the primary checkpoint is a scanner called Trivy. It is globally trusted to detect vulnerabilities and exposed secrets before code ever reaches a user. In March 2026, the threat actor known as TeamPCP successfully breached the environment of Trivy's maintainers, Aqua Security. Rather than modifying the scanner's source code, the attackers hijacked the system that delivers that code to the end user. By compromising the security scanner itself, the attackers turned a core defense mechanism into a tool for silent, system-wide infection. In a typical Git environment, a version tag is a pointer designed to lock a release name to a specific, unchangeable snapshot of code. But because tags are mutable, they can be reassigned. Attackers forced-pushed 75 historical tags, pointing them toward new malicious commits. To hide the forgery, they cloned the original commit metadata. They copied the exact author names, emails, and timestamps from releases as far back as 2021, making the malicious updates look identical to the legitimate ones they replaced. The attackers spared the single latest tag, 0.35.0. Leaving the current release untouched ensured maintainers monitoring the active codebase wouldn't see any immediate anomalies. Exploiting the mutable nature of these tags allowed TeamPCP to bypass traditional code review defenses, planting malware inside trusted historical releases. When a developer pulled a poisoned version, a script called the TeamPCP Cloud Stealer executed immediately. It ran its theft operation right before the legitimate Trivy scan, allowing the normal security logs to print to the screen as expected. On GitHub-hosted environments, the malware used passwordless sudo commands to dump the process memory. Memory is the temporary workspace where an active program stores its live data. The script scraped this area to extract hidden JSON secrets, catching passwords and access keys in plain text. JSON is a standard text format used to store and transport data. On self-hosted runners, the malware combed the file system to harvest SSH keys, cloud provider credentials, and even cryptocurrency wallets. The script encrypted the data and transmitted it to an external domain, cleverly typo-squatted as scan.aquasecurity.org. If blocked, the malware utilized the victim's GitHub token to generate a public repository named TeamPCP docs to host the encrypted data. This dual-pronged strategy ensured the threat actor rarely lost access to stolen credentials. Even if their external servers were blocked by firewalls, the stolen data remained fully accessible on GitHub's own highly trusted infrastructure. The stolen credentials gave the attackers immediate access to the broader software ecosystem. Using these harvested keys, the threat actors infiltrated downstream NPM packages. NPM is the default package manager for the JavaScript runtime environment, used to share and distribute code libraries globally. Once inside these packages, they deployed the CanisterWorm. This worm utilized decentralized blockchain infrastructure to systematically infect interconnected libraries across the globe. The attack culminated in the deployment of targeted wiper malware. This payload was designed to locate and destroy Kubernetes clusters operating in Iran. Kubernetes is an open-source system for automating the deployment and management of containerized applications. With over 10,000 workflows pulling from these tags, the impact reached deep into the supply chains of projects like Emil Group and Teal.io. Stolen credentials from these targets were then used to deploy self-propagating worms and malware that wiped entire Kubernetes clusters. The modern software supply chain's reliance on mutable version tags is a structural flaw. Pointers that can be silently rewritten offer zero guarantees of code integrity. If your organization ran Trivy in March 2026, you must assume systemic compromise. Every secret and access token exposed to that pipeline must be rotated immediately. To prevent these attacks, GitHub Actions must be pinned to full, immutable cryptographic SHA hashes. A SHA hash is a unique 40-character signature generated from the exact contents of a file, ensuring the code cannot be altered without breaking the signature. Blind trust in automated security tooling leaves networks exposed. To survive the modern threat landscape, that trust must be replaced with strict cryptographic certainty.